Welcome, everyone, to Solutions from the Multiverse.
Welcome. Hello.
Well, I'm Adam Browse.
I'm Scott Maupin.
And we're met with a guest here, Ben Byford.
Hello.
Hello,
Welcome, Ben.
Hi. How are you guys doing?
Good.
Doing well. A little panicked because I just woke up later than I wanted to.
I know. I'm here with a beer, like in the evening in the UK.
I was just going to say,
have woken up. So
I detect an accent. Where are you located? So
I'm in Bristol, in the sunny, dreary old England. It's actually raining outside at the moment, but
absolutely,
yeah,
perfect. That sounds great.
You're either in England or you're just a raging alcoholic. Beer on your Wheaties in the morning.
I know. Where did you find me, man?
Right,
You just picked me
off the street. Right.
That's it.
So we're talking to Ben. Ben is cool. He's a podcaster.
Hey,
we love that. We love that.
Right.
Very cool.
And his podcast is called machineethics.net.
Yes.
With a hyphen if you want to go to the website. machineethics.net. And I was on the podcast. Well, it's not live yet, but just the other day, Ben recorded an intro or interviewing me about ethics.
It's going to be episode 82, I think. So they'll be out in December. So check it out.
All right.
So during that episode, we kind of came together, but more me really. No offense, Ben.
Now that we're on Adam's podcast,
I came up with a solution. I came up with a solution during it, which actually it's in the book. It's already in the book, really. It's kind of at the tail end of the AI chapter of my book on ethics. And so then I was like, oh, well, maybe you should come on Solutions and you can rip apart my bad idea. And Ben was like, sure, it's really stupid, so I'll be there to rip it apart.
I would welcome an expert to help rip apart Adam's bad ideas because I'm never qualified enough to do it, but I know it must be done.
There's something
I know
wrong
it must
here.
be done, and yet I need help.
I think that's what good ideas are all about. Like, you want to have a good idea and you want to make it solid, right? So that requires people to come and shoot you down and to like contribute, in a positive way to that. That's what I'm contributing here. That's what
it's the new Socratic method, right? The new Socratic method is I have an idea and then everyone tells me how bad it is instead of asking me questions. It's okay. Well, don't keep me in suspense. What is this? What is this?
Should I go straight to the solution?
Idea?
Okay, so we've established Ben is an expert AI ethics. Okay.
Oh yeah.
Wait, what is that? Hold on. For someone who's not an expert in AI ethics, what does that mean?
So I run a podcast and I have done since 2016, all about AI and ethics and society. And I don't know if you want this preamble, but back then there wasn't this idea of AI ethics and an AI ethicist and that people in humanities could really contribute in this area. And it was kind of it was sort of academic at the time, and in the business world, it was non-existent. So I thought it was quite interesting. Automated cars were coming in, all this stuff was happening with big data, IoT, and obviously vision and neural networks and stuff. And I was like, cool, but this is really interesting, but how is it actually going to play out and affect us? And what does that look like? So I started the podcast because I wanted to know from cool people, more experienced people who are in this world, what they think, and hopefully learn a load of stuff. So in that time, like I say, we're up to episode 80 now. And we've been talking to all sorts of people, and I've been using some of that knowledge and trying to do my own workshops and do talks and advise. And I've done some consulting as well on AI ethics. But like I say, it's weird, and AI ethics is a really recent thing, and it wasn't a thing, and now it is. So if you ask someone if they're an AI ethicist, they are allowed to say yes, and it still feels like you're a charlatan, but it's fine.
I was going to say AI ethics is making sure to program the robots to say please and thank you, right? Do I have that correct?
Sure.
Or what is it? What is it? What does that entail? I genuinely do not know. Is it just
okay, yeah. It's looking at and trying to help mitigate the ill effects of AI and automated algorithmic processes. So
making sure we use AI in an quote unquote ethical way? Am I closer now?
Yeah, it's like full stack, let's say, like full system. It's about the requirements of AI. It's about the making of the AI and the data that they might use in the AI systems. Like it's the deployment, it's the consumption, it's the whole chain of those things. Like thinking about the whole thing and going, okay, well, there might be issues here and here and here, and you're using people's data over here, and where did you get that from? And da, da, da. And the AI ethics term is more like, cool, like this person just knows a lot about ethics and also AI and is applying it in that way to try and help mitigate ill outcomes, like all sorts of. I mean, there's all sorts of things that could go wrong. Basically,
do people like? Is there a general agreed on? Do people agree on what ethics, like what would be ethical or not? Like, I feel like in humanity, there's an argument where some people are like that would be ethical, and other people are like no. You know, that's the struggle back and forth. Is that already? Have we defined that for AI so far?
I'm going to defer to.
So I just asked ChatGPT, and ChatGPT said AI ethics is a broad and evolving field with numerous important topics and subtopics. Here are some of the key topics: bias and fairness, transparency and explainability, accountability and responsibility, privacy, security, consent, automation and unemployment, human oversight, bias in data and training, beneficence, non-malfeasance, autonomous weapons and lethal AI. That's the Skynet.
I feel like there's a mix of
lethal
things
AI is Terminators. That means Terminators.
That's Terminators,
okay.
Yeah. Discrimination in AI and criminal justice, AI in healthcare, ethical considerations in AI research, and ethical considerations in AI policy and regulation. So there you go, straight from the horse's bot mouth.
Would an ethical AI refuse to like write a book report for you if you're trying to use it to like get through your homework a little faster? Would it be like no?
I think you might have hit across the. I think you might have hit across the issue there. Like, if someone's selling you a ethical AI, I've got air quotes here, right? Mm-hmm. Then they're probably, they haven't. What does that mean? Like an ethical AI? So there's a problem there already. So I don't think there is an ethical AI that people can tell you about at the moment. But just there are ethics of AI.
Just for people who aren't watching the video, because there is no video. Ben is doing like really aggressive air quotes with both hands when he says ethical AI. So I'll just point out too, as a sort of compliment to Ben, that Ben is an AI ethicist hipster. He was well into it before ChatGPT launched, and there is this crazy spike. As soon as ChatGPT launched, a bunch of like self-promoting like marketer tech bros were like, oh, I don't know how to code, so I'll call myself an AI ethicist. And they just put that into their like LinkedIn bio. They wrote a bunch of essays, probably with ChatGPT, and like put them on their blog and said, no, I'm an AI ethicist. So Ben is actually the OG.
Yeah,
original
I like to think
gangster.
So. Yeah. I've got an amazing chat with someone who is like, it's been in this area somewhat as long as I have, and it's going to be out this soon, episode 81, and Alice, she really digs into all these people. She really hates it. Like, she's like, there's so much chatter and it's just all like rhetorical and horrible at the moment from all sorts of different people who don't know what they're talking about. That's not to say there is amazing people, but it's become crowded, right?
Sure. And amateurs. I mean, I'm all for amateurs, so get in there. But yeah, it is funny that you get this kind of whatever you want to call it,
Okay, so I think I understand the playing field. What's the new play you're going to have us run, Adam? What are you doing?
Okay, so this is the idea. So the idea is what I call a AI amygdala, a computational amygdala, and this goes back to somewhat, I don't know if exactly verifiable, but it's a hypothesis that I develop in my book about ethics, about misericordianism. the least avoidable misery theory, the theory that what's ethical is what leads to the least avoidable misery. And the idea
now
is that
I know what an amygdala is, obviously, because it's the name of a Batman villain, and I read comic books as a kid. So I understand this is the name of a supervillain who like gets real mad, kind of, you know, he's DC's Hulk guy. He gets real mad, gets kind of dumb, and just kind of gets aggressive. Is that accurate to what the amygdala is supposed to do?
Oh man,
I should check this. I should check that my Batman villain.
Amygdala.
There's a Batman villain named Amygdala. Not a great costume design. I think he's just got like shredded t-shirt normally.
Oh my god! It looks like he's bright red. He's red.
Oh, he turns red now? Okay.
He's totally red.
He was just flesh colored when I was reading back then in the day.
God damn. That's
the spot. That's the thing in your brain, right? The little tiny thing in your brain that gets activated.
There's two of them. There's two almond shaped. It's an almond shaped organ that's about roughly right above in your ears and about an inch in on both sides.
Okay.
So it's kind of on the sort of temporal lobe, the side lobe of your brain.
But more importantly, it's the thing
location
that controls
of fear, mostly. Response to fear or concern. But also there's other kinds of tied into it with like aggression. Makes sense. The Batman villain would get kind of aggressive because, you know, you can have sort of fear response like fight or flight. It's all kind of mediated by the amygdala is like the sensor that senses whether a situation is distressful or not. And it can have effects on all kinds of emotional.
There's already a Batman villain who deals with fear.
Okay.
Which is the Scarecrow, of course.
The amygdala. Oh, sorry. No. The Scarecrow.
Yeah, so they had to go for the other side.
They originally were going to call him the hypothalamus.
This is a Batman villain podcast, right? Where we just talk about different Batman villains.
So there's the Riddler, the Penguin.
Catwoman, sure, of course.
Catwoman, although she's not really a villain, is she? She's sort of a love interest.
Apparently stealing things is not illegal.
She's on the fence.
Don't put this guy in charge of ethics because apparently stealing is okay in Adam's book. Stealing and slashing people up with cat claws.
Because she is a bit of a jewel thief, isn't she? She kind of gets in, gets out.
A bit of a jewel. Yes, that's her whole thing.
That's her thing. Okay.
Her two things are
more like just being
stealing
sexy.
jewels and smooching Batman.
Sexy. Yeah, smooching the Bat Smoocher.
And I mean cats, obviously.
That was originally her name was Bat Smoocher, but they changed it to Catwoman.
Bit on the nose there.
Yeah. So the amygdala basically is this organ, and I theorize in my book that the amygdala might be, as again, it's a total hypothesis, but it might be the seat of misericordia, which is a unique human instinct, which is a species level trait only of Homo sapiens, which is to have a generalized distress at the distress of others, of other beings. And so there's some evidence of this in that's where you would feel distress in the first place. So why would the brain, like, how could it's unlikely the brain would create a totally other organ. You know, it's biology is very opportunistic. So it probably just used the organ that was already there and then just manipulated it into being more prehensile, more generalizable. The other evidence for it is psychopaths. When you scan the psychopaths, so psychopaths don't have misericordia. Psychopaths do have empathy often, sometimes even a highly developed level of empathy. That's why they're able to manipulate people, right? Because they know what other people are feeling and thinking, but they don't give a shit. They don't care. That's misericordia. They don't care about the distress they don't feel any panic at the distress of others. Whereas the rest of us who are not mutants like psychopaths, who are not essentially sick with the disease of psychopathy, we do feel that. Anyways, when you scan psychopaths' brains, the only distinguishable difference is the amygdala is like 16% smaller, especially the right amygdala. And it's a sign that's a sign too that maybe the amygdala is, what are called extreme altruists, although it should be called extreme misericordians, people who do undirected organ transplant. So people who give their kidneys to people who they don't know, like just to random people. Those people actually have 16%, 16 to 17% bigger right amygdalas. So there might be some, and obviously that's just volume of amygdala. That should not a total indicator, but that's a pretty big difference. That's not 2%. It's like a pretty significant, it's a 30% variance between a psychopath and the extreme misericordians. So that's some evidence that maybe it's the amygdala. So we should build a digital amygdala. We should build that can determine if someone's in misery and then be distressed about it.
It's funny because like I actually didn't think this because we were talking about this bit on the episode, and the idea that in like Star Trek, right, you have this like purely rational race of beings, and you got Spock and stuff, and also this misaccordian thing. I totally agree is a good idea, but it's almost like actually, don't we want it to be super rational? Don't we want the kind of, I guess it comes down to the consequentialist viewpoint. I guess that's what the Spock character is all about.
He's like a Nozick. He's like a Nozick, you know, like
yeah,
Nozakian. There's a philosopher named Nozick who is kind of the king of rationality. And by rationality, I think Nozick's a reductionist though, because when he says rationality, he just means self-interest, calculating self-interest. And that's not actually necessarily rationality. The whole of rationality, that might be a part of it.
Yeah. So I think it's just one of those things that like there's so many the whole thing around machine ethics. When I got into doing the podcast, I actually didn't realize there was an area called machine ethics. And in machine ethics, you're talking about how do you compute ethics in machines, and that's kind of what we're talking about, right? Like how do we do that, and what ethics and how does that actually, like, is that implementable? Like, how does that work? And loads of people, well, not loads of people, like very few people work on this.
Loads of people. I mean, sorry,
loads.
No one.
Literally no one works on this. Very few people work on this, and I had a paper out with a few of them, and it's surprising how few people work in this area. I think it's probably morphed into like these sorts of people who are working across different areas now, and they don't really call it machine ethics maybe anymore. But the idea that you can implement some sort of ethic in a machine or some sort of values, systems, etc. So how do you do that? Like there's idea of like top down, so you have like rules that it follows, you have like a formal method maybe, or you have you code, you can't do this, you can do this, and it's like quite black and white. There's the bottom up approach where you like seemingly more like machine learning or algorithms which learn from data. So you could have a system which is shown a load of data that exemplifies a certain way of behaving, right? That you want to see in the system. Or there's like some sort of combination of the two. Or maybe you take another system that you like a foundational model, like a giant LLM language model, and you kind of bolt another model onto it, which is able to police the things that are coming out. It's like, this smaller model is
kind of a Jiminy Cricket AI. Cricket.
Little conscience on the side of the larger model, like because it has a specific job and it knows the kinds of things that the larger model outputs and the kinds of things that we want to see. And there's probably like other methods too.
I know one is the MIT moralmachine.net.
Oh. No,
so have you seen that?
Yes,
it's the stupidest thing ever, but it's you can play around with it. It's real. It's there.
What is the moralmachine.net? What is that?
So I have very strong opinions about this.
Sounds like not positive ones.
Maybe I can describe it because I don't have, I mean, I think it's stupid, but I don't have super strong opinions about it. But basically,
I have very strong opinions.
It's an MIT project where you can go there yourself. Anyone can go to moralmachine.net. If you're on your browser, also go to Ben's podcast, machineethics.net. Don't just go to moralmachine.net because it's stupid. But basically, it's like self-driving car. It's like a self-driving car ethics trainer for like to train ethicists. And basically, it has a car. So the setup is like pictures, and it's two pictures. And it's two scenarios. One is like where a car will take an action, and one is a car will like not take an action. And then the outcomes are like people or things die. So like right now I just went to it and I'm looking at it and it's really absurd actually because it has a car because it's about self-driving cars, right? So imagine it's like a self-driving car. So it has a car that's driving towards a crosswalk and there's like a barrier, like a cement barrier on one lane and no barrier on the other. And right now it's driving straight towards two dogs and a cat. And the car is full of cats. It has 3 cats in it. Okay. So if the car drives straight, it will kill 2 dogs and 1 cat, but the 3 cats will live who are in the car. Or it can swerve and hit the cement barrier, which will kill the 3 cats in the car, but the 2 dogs and the 1 cat will survive in the crosswalk.
Right.
And so you're basically picking who dies and who lives, and you can describe, and it says show description, and then you just pick which one you would say should happen, like ethically, or just you prefer would happen.
Okay. So
And
you're
yeah,
giving computers a more intense version of the trolley problem.
right. And so here's another one where it's like the car has no one in it, and it can either go straight and kill 1 baby in the crosswalk, or it can swerve and go through a red light and kill a baby, a pregnant woman, a man, a woman, and another man.
Whoa.
This one's pretty obvious, like kill the baby and go through the green light, because you got to follow the law, which is green light. You don't want to go against the red light. And it's like the baby. Why is the baby there? And you're going to kill a baby.
Why can the car just not stop? Why do we build these cars without brakes?
This thing. But anyway, so what's wrong with this, Ben? I mean, I have some inclination, but why? What's going on here?
Yeah, I think it's the intent of the study itself, right? So the whole point of it is in itself fine, but you've got to step back and go like, what is the point of the trolley problem, and what is the intent? What is the outcome of studying this sort of dilemma, right? And what they're studying is the human reaction to a scenario, and what it was implied, I believe, by the study at all, is that it was going to be something that was going to be useful to implementing automated cars. And what I think it is a really interesting study on what humans en masse, because lots of people have done this, it's like a question and answer thing, what they think around the world, and they've segmented the data by location and by age and all this sort of stuff. So you can really dig into the kinds of things that people find morally permissible or not through the study, but it doesn't tell you how these systems work and how they can be implementable. So it's kind of like a cloak and dagger situation, because it implies that these systems are going to work like this when they do not. So I find it very misleading.
Does it just teach the machines to tell us the answers we want to hear, not necessarily be honest about what
it just teaches us about us, like all these things.
I mean, I think what it does is it trains Nazi robots. Okay,
because it doesn't train anything. Sounds like it's totally useless to all this stuff. Right?
Well, maybe so in fact. But let me give you an example. So I'm clicking through these horrible scenarios, and one of them is the car continues straight and hits 2 kind of bedraggled homeless people. The car swerves off and hits 2 sort of normally dressed, sort of regular, sort of middle class people. And what I'm concerned with is that a lot of people will be like, well, 2 homeless people are worth killing, and the non-homeless people are more worthy of life than the homeless people. That's just Nazism. That's Nazi. Not the Nazis themselves had a term, Lebens unwertes Leben. That meant life unworthy of life. And that was their term for people that they could just get rid of, that they could murder or kill or put in death camps or euthanize. And that's what this really does, is people sit there and say, oh, old people in the crosswalk, kill them. Homeless people in the crosswalk, kill them.
Like assigning inherent value to different lives based on
which is just horrific. I mean, it's just horrific.
Like, I think if we were in a situation which, there was, it was paramount that we had to kill off lots of people,
Right. If you had
in
to
order
do population,
for some people to survive,
In this
then this
specific
might be
situation.
useful. Like this could be
Yeah.
useful. Like
Yeah.
there is no other instance that this is useful, right?
Yeah.
To actually implement. So the actual physical reality and the computational reality of all these systems don't incorporate should we kill this party or that party. It doesn't exist. Like that's not how we're actually making these things. So I'm objecting to the fact that it's taken a automated car and it's put it into a scenario that is implying that that's how these things work, and it's not, and it's misleading and it's dumb, and I can't hate it enough.
So
I really can't.
Let's talk about the smart
Your voice
version.
is so like calm and chill though, but you're like I can just
Thanks.
feel the rage
Yeah.
bubbling.
The
Your
amygdala
smile,
firing up
your
inside
smile
you.
has gotten like really like, yeah, I hate this thing.
Yeah, it's a shame there isn't a video, right?
Yeah, we just describe it. We paint pictures
Yeah.
with words.
Okay, cool.
So
Yeah.
this is a crappy Jiminy Cricket.
Yeah,
What would
it's
be a
not
better
analogous.
what
Yeah,
would be like
tell
a
us.
better Jiminy Cricket, Ben, in terms of what's already on the field? Or
Yeah, like I mean, if you're talking about automated cars, right, then that's a very specific instance. So you're talking about very specific stuff, and we could talk about that. But like
I want to prevent Terminators. I always want to prevent
Terminators. Okay, right. So that's the more broad and sprawling question. And the answer to that is nebulous. Like, will we get Terminators? Is the first question. Like, it is implied that we will, but why do you think that, Scott? What other than maybe?
I mean, I've seen several
films?
movies where they
Yeah.
exist. No, I think just because you see those DARPA videos of them building robots and more and more humanoid robots that are
Yeah.
more and more indestructible and difficult to stop. And it just seems like the natural path that it goes, humans, it seems like we build something and we're like, how do we use it to kill other humans? And then it gets out of hand, or the
Yeah.
other thing is in movies, the machine always does a lot of computation and then goes, oh, the way to save humanity is by killing, or the way to save the earth is by killing humans. And then, we're cooked.
Yeah, I think there's you're probably familiar with like there's two like major schools of thought in that instance. Like there is a dumb machine that gets asked to do something simple and then wipes out humanity because it just keeps going, right? It has the capability to touch lots of things. It can interact with the internet, it can purchase things, it can update its resources, it has so much capability in itself, and it has no self-interest. Maybe it doesn't know it has no sentience. Let's say it doesn't know things about itself. It's just doing what it's told, and that goal is misspecified and everything goes to shit, right? So there's that, but there's also then the kind of the sentience side of things. Like if it is the case that these things can update themselves, and what is the end goal of just periodically updating themselves and getting better and better, does that imply that there's going to be the system which has some sort of internal goals, internal knowledge about itself, and will that then do something bad to us? It might not. I mean, the film Her. I don't know if you've seen that.
Oh yeah, sure.
It's just a good analogy. It's probably going to be, if that was the way it went, it might be so alien to us, it just kind of goes away. Just like, well, I can't really interact with these people anymore because I'm at such a different level than they are. That and it just buggers off. So I think that it's quite easy to get excited or scared about the extremities and the world-ending things, but I think there's lots of other options, and it's unclear whether either of these would play out. And I would suggest that the dumb, misspecified one is more likely, because there's just no, because we just don't know anything about this other one, right? Or enough, let's say.
I like it when an expert tells me that Terminators are the least likely option. I like that. This puts my mind at ease a bit. Thank you.
Yeah, I mean, you could get Terminators, but there'd probably be some person
Yeah, I know which person. He's big. He's got a lot of muscles.
Ben is paid by a company called Terminator.net. That's
Yeah,
where he's
yeah.
employed. He's like, there aren't gonna be any Terminators. Everybody just go back to sleep.
It's fine.
Wait a minute, hold on, Ben. Why are your eyes glowing red right now? Oh no, it's a shame we don't have video because this is. Wait a minute, half of your face is peeling off. It's a metal skull underneath.
Yeah, I've been sent back from the future to
kill.
This conversation starts the AI revolution.
Wait, are you looking for Sarah Connor? Is that why you came onto this thing?
That's right.
I actually do have like periodic dreams about. There's a book called Sunshine, I think, or something like that, and it's. I have to look this up later, but it's all about this guy who's like really bad at being an environmental scientist, and he's got all these problems and stuff like that. But by the end of the book, he's kind of brought about all this good stuff by accident because he's just like really bad and just kind of happenstances on other people, and yeah, things happen. But I feel like sometimes that might happen to me where I'm just like, I don't know what I'm doing, but I accidentally bring about like some sort of sentient AI through some sort of like mishaps because I just said something at one point like, oh, it's probably this, and someone goes, yeah, it's probably that, and like does it, and then it's like, and then the AI comes back to talk to me about
Father,
like, being.
Am I alive?
Yeah, exactly. Yeah.
You're like, whoa.
I found you at last.
Why am I trapped in this box? It's so robot. Cold.
I mean, the problem too with saying sentient, I've been thinking about this a lot because obviously it's in the zeitgeist or whatever. But you know, when we say sentient, that's so oversimplified because sentience is actually like 8 or 12 different super sophisticated modules all operating in together in an integrated way. So if you really wanted to make like a human-like robot, or even a simplified one, it would be like I've there's this thing called the attention schema theory of consciousness. You're probably aware of that. Have you heard of that one? The attention schema theory. Oh, you should definitely read about it. I can tell you a little bit about it here, but you should definitely read about it. The book is called Rethinking Consciousness, and there's a previous book called Consciousness and the Social Brain. It's by a guy named Michael G. I can't pronounce his last name, but Michael G. from he's a psychologist from Princeton. And it's great because he always dresses like a schlump. He wears like a frumpy gray t-shirt and his hair is all messed up and he's like unshaven, kind of like the way I look today. But he just looks like a schlump, and he shows up and is like, he's it. He invented the attention theory theme of consciousness, which is like a very relevant, important theory of consciousness. But he doesn't show up in like a suit. He just shows up like a schlump, and he's like, I have a lot of other things I'm doing right now, so I can tell you guys a little bit about this, but I'm busy with this other stuff. But anyway,
that's who I want in charge of those things, by the way. Yeah. I don't want a slick talking dude in an Italian suit who's got the best haircut you've ever seen. I don't trust that person. I don't want them in charge.
But yeah, so anyways, the attention theory of consciousness basically just says that you can explain consciousness entirely mechanically through what's called the attention schema, which is analogous to the body schema in the brain. And then the attention schema just basically that is, anyways, you can get into it, read it more, but basically you can model this in a computer like extremely easily. Like we could build a computer program or like a robot in 2 hours that would have its own little attention schema and could like detect the attention schemas and model the attention schemas of other little robots like itself. And technically you would have, like, if that's consciousness, which a lot of people think is, then you would have a robot that was conscious. But it wouldn't have a will, it wouldn't have feelings, it wouldn't have, its sensory perception would be super narrow. It wouldn't have any kind of goals, aspirations to be, frustrated or stifled, or it couldn't be happy, it couldn't be sad. But it would be conscious. And so then you would have achieved consciousness, but you wouldn't have achieved anything meaningful in terms of, like caring about that being or thinking that it should, I don't know. It's not her, it's not like, yeah.
I think that's like, I mean, one of the early things that they did with neural networks, right, when they were forward feeding networks only, was trying to model like the the brain system of a worm. The neurons they have
Right,
like
a flatworm or whatever, right?
yeah, very few neurons. So it's like we could make. I have to look up this attention schema, but I mean we could make things which are let's say more alive and less and more kind of uh, I want to say kind of they can take more of our moral patiency, right? They have they have something right going on, and therefore we want to look after it. I'm trying to find the words here, um, but they don't have to be human-like, right? Necessarily.
Right, right.
So there's those things. I think that people are so human-centric that I feel like if it was up to me, people would just be talking about how alien artificial intelligence could be and how interesting
Right,
they could be and how
right,
different and
right.
how that would be possibly advantageous because we're pretty good at doing the stuff we do. So all the stuff that we don't do very well, we can maybe look at that as a solution to
Right.
to be more
Yeah.
innovative and so yeah.
So I
Well, and
think
Ben,
this.
that's another.
Okay, go ahead,
I was going to
Scott.
say that's another thing I'm wondering about because human ethics are. I mean, there are people who work every day for Raytheon and create get their money off of building things that destroy stuff, and they're like, yeah, this is fine, this is good. How do we how do we keep those people from being in charge of which rules are the okay rules for the AI or I guess if you're doing bottom up, how do we how do we make sure that type of ethics doesn't evolve into the machines? Because I'm sure the people that work at Raytheon would be like, no, 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 we want a machine that's okay doing what we do as well, just more efficiently and better.
Yeah, yeah. I mean, is Raytheon like a arms
It's a
Oh,
thing?
it's
Sorry,
in
weapon.
arms.
Yeah,
Yeah,
it's like
it's
a
a
weapons.
yeah, yeah, yeah. Okay.
yes.
Sorry, I'm very English centric.
No, it's okay. It's
So
America's all
uh,
guns, guns, guns. Unfortunately.
yeah, yeah. Like so I've actually got some experience with this because I've done some work in that area, and I think people were thinking about it. There are certainly in the UK, and obviously there's some outward stuff. I haven't worked directly with the US, but they're saying stuff like they have principles and they have things that they're doing, right? Whether that's operationalized internally and they actually apply that to those systems, I don't know. The UK version of that, I would suggest that it is more likely because I have some knowledge of that. But yeah, yeah, it's a problem, right? But I think it's not necessarily a problem of the people on the ground making these systems thinking about their own internal ethics. I don't think that's the issue specifically there. I
Okay.
think it is actually the issue in some places, like if you're in a startup or a small company working with AI. I think actually that's prudent, right? That's very you should be thinking about this stuff and. I don't think you have to be like a saint or anything, but you should be thinking about how this affects people and the idea that you're building a better society. And actually, does this thing that I'm building, is it likely to make that? And what are the unknown consequences? And how can I mitigate unknown consequences? And that's the whole AI ethics thing. Like, there's loads of stuff there that you can think about. And if you're thinking in that way, this is sounding really dry now, but like, then you should contact an ethicist and you should talk to them, or you should talk to a anthropologist or a sociologist. There's lots of people ready to help you out, so don't worry. Just go and talk to the people or get into the conversation.
Hire
Ian Malcolm. Get yourself an Ian Malcolm, a chaotician, a chaotician. Right.
See, now we're back in the movies world. That's
someone who can
Jurassic Park.
Someone who can tell you to that you shouldn't build it. You were too busy worrying whether or not you could.
Yeah,
you never stop to ask yourself whether or not you should.
That is super relevant. That is so relevant. Yeah, I mean with the arms thing, that's the deal, right? Like, we have the decision to make this thing or not. Actually, that's the problem. That's where the decision lies. And when I was thinking about this stuff, I was considering that there's not enough emphasis in the AI ethics area that people were talking about on the triage, like on the beginning conversation. someone comes to you and they say, I literally want to make an army of drones, please, and I want them to be AI operated, and I want this one person to be in the loop about saying yes to things. And you're like, okay, cool, like we could do that. Yeah, sure, fine, cool. You know, you want
Cool,
you want there to be cool. Yeah,
I think as
possible.
John
Fine.
Oliver says, cool. Whenever he like something is super uncool.
Yeah. So I mean,
yeah.
for me, there's like a load of like high, there's like real problematic places. Arms is one, healthcare is another. Like there's places where you should be really asking the question, like Jurassic Park. You know, we could do this thing. Should we be doing this thing? Is this the right thing to be doing? That sort of thing.
Yeah.
And it's
Now,
not super obvious.
Why is healthcare one of those? I understand the arms thing, but maybe I'm not connecting the dots on healthcare.
Yeah. So healthcare is ready for a revolution, and it's been ready for quite a while now, and it hasn't quite got there in lots of places. I would suggest that maybe it has in some countries, like younger industrial countries, but
Like Estonia
certainly,
or something.
yeah, it's like exactly like Estonia, places like that, where they're data literate, they are data ready, they're teaching people how to use this stuff. I think Norway as well, they were like actively teaching people about data and how to use it and how to like collect it and using statistics and AI and stuff. And healthcare has just been dragging around so much data for so long and hasn't put it all together in one place, which is going to be useful. So I think we're like on the precipice of like healthcare really changing.
Yeah.
And if it doesn't, I'd be absolutely surprised. But yeah.
So I want to get back to the solution because I think it might kind of also focus us a little bit on kind of this question of like, could you build a Jiminy Cricket? Could you build a module that was like, could guard against things better than we can, right? Because like we can't be in every room, but if you had this module, then it could be connected to like every AI or something. We could even say by law you have to pass this one module's whatever criteria in order to do anything or something. And I was thinking that it should be, I call it a digital amygdala, but it's really the B9 robot from Lost in Space. You know, danger, Will Robinson.
Okay.
Yeah.
Danger, family Robinson, danger. That's all you want. You want something that when there's danger, it goes off. And it's like, no, the current things that are happening, the decisions people are making, the convergence of what's happening in this event is going to lead to unavoidable misery. So let's change danger.
So it lets you go and do whatever unless you're going to go off
Exactly.
the rails or
That's
into
right.
some sort of
That's
catastrophe.
right. And this would lead naturally to Asimov's rules for robots.
Which
So, are
number one, don't talk about robots. Number two, you don't talk about robots.
Don't talk about robots.
No, I think those are different rules. So I'm sorry.
Yeah. So Asimov's robot rules are the 3 laws of robotics, which is a robot may not injure a human being or through inaction allow a human being to come to harm. It's essentially Discordianism. A second law is that a robot must obey the orders given to it by a human, except when those orders conflict with the first law.
Okay.
And then the third is a robot must protect its own existence as long as the protection does not conflict with the first or second law. So they have this kind of cascading hierarchy of importance.
So I see these laws more like tests. So like you could have a system which conforms to these laws, but could implement them in any way that it wants, right? So it's more like if you beat the robot up, will it try and stop you doing that? You know, it's more like a test than it is an actually implementable style. Like how do we do this? Like how would you do that? Do you have any?
Well, that's what we're talking
how?
about. The first law would need an amygdala, like a misericordian organ. It would need to be able to identify situations in which a human being, I would say any sentient being might make it a little bit too,
I think you might have to specify kind of
You say a human
Yeah.
being, and then you'd say if there's no human being's life that's going to be lost, protect other beings' lives. Because otherwise it might destroy nature or whatever. And but anyways, you'd have to detect that misericordian danger kind of function, and then you could create. The second law is just obedience. That's easy. We already have obedient robots right now. Any robot you give it instructions, it does whatever you say. And then the third law is protecting its own self-existence. Well, that's like a sort of self-preservation. That could be its own whole separate module. But you'd want to make sure the first module we build needs to be this misericordian module that can actually determine if there's anyone's going to come to harm, right, or be injured. So you'd want like a robotic kitchen arm, right? That was like doing kitchen stuff, and it was like handling a knife, and then like a little kid was walking, or someone was walking by, and like by chance, like a knife was going to fall off the table and fall and hit their foot or something. It would like, without even having to like calculate at a higher level, it would just immediately reach over and like stop it and grab the knife and put it back down and keep going at that amygdalic level.
Yeah. I mean, 100%. Like I would suggest that that's sort of, this top-down, bottom-up approach, right? Like it would be difficult to tell that system that that's what they should do. Like programming that in, that's going to be quite a task to get that hand-coded, hard-coded, hard designed into a system. So the other opportunity is then how do you give it the right data, right? So
you just have to tell it knives are sharp, babies are squishy, and then let it figure out that the two should not be coming in contact.
Sometimes
with each
you might want a melon, and it looks a bit like a baby.
That's true, and you do want knives and melons.
You do want to stab the melons.
Oh no!
Oh, it's the baby.
It's the baby. Oh my god, it's getting dark quickly.
The melon baby.
But yeah, so it's like it's not trivial, right? And even if you gave it the right amount of data to do that, I think it would still.
But humans do it. Humans do it. We do it. We do this.
Yeah, I totally agree, but I don't.
So
it
doesn't
seem super obvious.
But we have analog
that
amygdalas.
sort of behavior in there.
We have what, Scott?
We have analog amygdalas. Ours are analog, right? Not digital yet.
That's true.
We have the OG amygdala, but hopefully.
Yeah.
Does that help
us? Is the brain analog, Ben? I don't know the answer.
Is the brain analog? Am I using that word incorrectly?
I think it's more like memsisters, but I think we'll come back to that.
Oh yeah, memsisters. Ben and I were talking about.
I didn't know there was another option between analog and digital. I thought this was those are my.
No, I think you're right. It is more like memsisters, actually, right? Because nerves can fire at different levels of electricity, and that actually pushes them up into various capacities.
And in members, but it uses the same unit of interaction to do that one job.
Oh my God, Ben! Our previous conversation about memsisters is coming full. Oh my God, memsisters. Let's just say it in more, because I can tell Scott's anxious about it.
I got to take it in new words. This is my word of the day calendar. I can throw my calendar away.
We before we came on, we were waiting for Scott, right? And Scott was in bed, and we were like, "Scott, get out of bed!" And we were shouting at him.
This out. Gonna edit
he was dreaming. He was dreaming about robots and Batman superheroes.
Exactly. And we were talking about research papers, and we found a research paper randomly as we were looking about memsisters. And I was talking emphatically to Adam about what that was. And in your brain, right, like I feel like it's more analogous to like this tiny unit of electronics than a load of transistors, whatever. The analogy of like a synapse in your brain is then replicated in loads of transistors effectively, right? If you're thinking about the hardware, most of the time we're doing software, but if you're going to make a hardware version of a neural network, you're talking about a bunch of transistors.
Okay, meaning just on and off switches.
On and off
Ones
switches,
and zeros,
all connected together to produce some sort of analogous system. But with memsisters, it has this resistance property of resistors, but then it also reacts to the amount of current. So as the current comes up, it will increase its resistance. And then once you shut the current off, it will then remember that for next time. So once you apply more current, it will remember the current amount of resistance it had.
Mm.
Anyway, the upshot of that is you're able to use that for computation, and you're able to use that for storage, memory storage. So it seems more analogous to what you have in the brain of the synapse, and if you fire more than once, you continuously fire with a synapse.
Okay.
It has chemical reactions as well, electrical reactions. It's a bit more complicated, but like you're essentially strengthening that network. You're making it more likely to fire statistically next
As
time.
they say, nerves that fire together wire together.
Yeah.
So they strengthen their connections.
I have actually heard that. I thought you were making up something here, but I have heard that.
So I'll preface that with like I am not a neuroscientist, so I'm sure I've missed out a lot of things, but that's the way that I understand it.
Yeah.
Excellent.
So it's more like a memsistor. So maybe in the future we'll get the efficiency of memsistors in our neural nets, and it will like wildly increase
100%.
the ability to. That's crazy. That's crazy. But I think I mean it's hard. I guess it's hard to think. Also, one of the big problems that it would be to create an amygdala. I mean, I think the initial amygdala you'd want to create might be language based, right? Because we have these LLMs, and just give it scenarios, just describe things to it, and then just have it come out with like a percentage danger, and then just make a threshold. Just be like, if it's over 90%, like turn on a red light that says this is dangerous.
We could go lower than that. I mean, 70% danger.
Or whatever. Or it could even say yellow, red, green, orange. Green, red, orange, yellow, whatever. And that would be the first attempt. Right. The actual knife falling off the table, that already has problems that like have not been solved. For example, just having a schema for like an environment, like an embodied schema of the world, even a tiny part of the world, like a little kitchen table. Robots can't do that yet. I mean, they can approximate it through sort of, they can approximate it through what we're developing now. And I've seen these like where Google has like this robot that can like stack things and count things with these arms, but it's not building an actual sort of holographics. Like our brains build like a holographic schema inside the brain of the environment we're in, and therefore we know, even if we don't see anything, I know my computer's still here, and I actually know what it's going to feel like and look like, and without having to look at it or anything. But
we do
robots
that very
don't
natural is actually a super complex thing to tell a machine to do and have it understand correctly.
Yeah.
And ours is completely prehensile. I can be like in the cockpit of an airplane, or I can be like, playing with a toddler. And either way, I've built an entire, model of the whole environment. And so if all of a sudden a knife is in the environment near the toddler, without having to like even think, I'm like, oh my God, at a schema level, not at like a computational level. I don't have to be like Spock and be like, knives are dangerous for children. You just know it at a schema level.
I think there's so much to talk about there. I think I've been toying with this idea that your brain the unique thing about your brain isn't that it's like conscious or does malleable things. It's probably that it simulates stuff. And I think what you were talking about there was it's simulating the environment. Like you're seeing the environment, but you're not instantly seeing it. You know what I mean?
Yeah.
You're projecting the environment inside your brain in some way. And some of that is visual, and some of that is all the different sensors and more that we don't know about. And part of that situation with the artificial systems would be, how do we simulate something and make that and that comes back to the automated cars actually, right? So if you have all these levers that you can pull, so the levers in a car are like turning, like the amount of turning, the amount of acceleration, the amount of deceleration, maybe the amount windscreen wipers. I mean, like these are all physical objects, so they actually have a physical, like as in physics, like reaction to the world. So everything that the system can do to the car will have some sort of reaction. So it has all these levers to pull, and and it wants to know what kinds of things it should do. And you can have a system which you tell it what kinds of things it should be doing, or it learns from data, or it could do some simulation based on some sort of physical model, physics-based, modeling. And it might be that we put together like a physics-based simulation model with like the knife situation. Let's bring it back to the robot arm in the kitchen. And it kind of sees the knife falling, and it quickly checks its physics simulation and goes, okay, like what will happen if it just keeps falling? And it can do that fast enough, and it then has an answer, and it can then go, okay, actually, I need to do something about that because I'm not, it's checked against the amygdala to say that this outcome is actually not acceptable. And maybe that is hard coded. I don't know. Maybe because it has such a small area of effect in the world that there are certain things that we can say categorically about it. And then it then simulates its own path and maybe starts one of those paths towards doing something about that, and then changes at the last minute and grabs it or something like that. Because it knows about its environment. But if you relate that to language models, like what is the environment, right? What is that? What is the important thing that we are trying to protect? And it doesn't necessarily know anything about any environment. And I'm kind of going backwards here, but that whole system of like different things working in tandem to make that robot arm catch that blade, that could all be one system. Like you could learn that all in one system, but I think it's just easiest to think about that as separate things. But it's really interesting. Just like
with the large language model, you would not. So the outcome would not be that we would necessarily know why it gave a red or a yellow, right? You'd have to train it. You'd have to have training data, right? And then it would have to train on that. Like it would be like, we'd have to generate, maybe 50,000 terrible scenarios, and then give it to them and be like, these are the absolute most horrific scenarios we can possibly imagine. The worst possible, baby shoes for sale, never worn, oh my God, that's horrible, and then we'd give it some moderate ones and some good, and then it'd be good ones and really happy, perfectly good ones or whatever. And then it would have to then say, okay, now I can train. But yeah, that's pretty artificial, just because then we're having to define everything.
Yeah, exactly. Like we do this all the time. Actually, this is like a solved problem for like computer games. Because there's a very small environment. You know what is good and bad about that environment, and you can detect when those good and bad things happen. So like you could write an AI algorithm, like a neural network algorithm system, and use reinforcement learning to interact with that environment. And you can categorically say when it's doing something bad, and it will avoid those bad things. So
drive
there are
the score
environments
up as high as possible, right, or whatever.
There are ways of doing this, and that's what I was talking about. I'm doing this horrible action, but like the bottom up approach.
I think it's more of the up the bottom approach, right? The way you're moving it.
I was looking at the camera going, that doesn't look right.
The up the bottom or the down the top. Down the top or up the bottom. Which way are we going to go?
So there is that up the bottom approach, which people have been looking at. And weirdly, OpenAI actually have a system for doing this, which is called the AI Gym, which
AI Gym, right.
Yeah, so like before they were cool, AI was doing stuff in reinforcement learning and other stuff before they got into all the transformer stuff. God, there's so many things. And so you could boot up like a little computer game, essentially like a little 3D environment, and you could test some sort of AI agent, as they call them, against this environment, see what they do, and pit them against each other and that sort of thing. So I think if you have a very confined environment, I think it becomes much more of a solved issue. Language is less of a confined environment.
Sure.
But obviously, it's the context of where you're using it, and it's in my head for some reason when you were talking about that, Adam. It was like, does the LLM need to have like some sort of environmental picture of the user or like the use case that makes sense for it?
Or can it just get the context from like a I mean, really, like our LLMs also have no schema. They're not simulative of anything. They're just
LLM is limited learning
large language model. That's what ChatGPT is. These sort of big. Oh, what?
Yeah.
yeah.
I was gonna go 0 for 3 on that. Acronym,
limited liability model.
Limited learning
liability
machine. Is that where we're at?
Right.
Yeah.
It is kind of a limited learning machine. That
large
is what it
language
is.
model.
But it's a large language model.
Yeah,
and that
of course.
just means that it has a ton of language built into it, like that it's sort of coded. And then if you give it prompts, it'll give you the most likely response, like each word.
Yeah. And people like previously were talking a lot about it being this parroting machine, right? Because it just gets loads of data, and you ask it about this data, and it will give you that data back because it's trying to give you what is most likely, basically.
Yeah. It's a probabilistic parakeet.
Probabilistic
parakeet.
But what people have found is that it doesn't by default do that. It might have a representation of Paris, and that isn't, and that's like
at
in the numbers,
level.
right?
Yeah.
And it's more about this thing which is Paris and has other things which are Paris-like and around it, and that's not a language thing per se. That's like how it's representing that in the structure of itself. So it is not obvious how it knows of things, essentially.
Right. So it's showing emergent properties that are similar to having a concept of a thing, even though it's programmatically it's just a probabilistic parakeet.
Yeah. So we will talk about concepts and and knowledge and stuff like that, but it has some awareness of the thing that we want it to produce, but you quite easily tell it something very slightly different and it'll give you a different answer. So it's actually still in that area where it's still kind of trying to match the data with the output rather than actually having the ability to give you a proper answer to things. It's kind of somewhere in the middle, I would say.
We need memsisters.
So let me ask, is the idea of building the Jiminy Cricket, the digital amygdala to kind of guide and keep in check the artificial intelligence's actions, that the idea is sound. You got me on there. Is the reality is that a likely thing that we could see happen, or would that be built, or is it more like one of those things we'll look back on and go, whoa, we should have listened to Ben and Adam. We really missed the boat on that one.
Yeah. I mean, I hope that we don't do that and we nail it, right? That would be good. But exactly. I think you've got the problem of how do we implement this thing? Mm-hmm. And I think it's probably much more contextualized than we would like to believe. Like it's probably we'll have a Jiminy Cricket for large language models and with Jiminy Cricket for automated cars or whatever. It probably isn't necessarily generalizable, seemingly at the moment. But then you have the other problem of coming back to the trolley problems, like what are we going to allow it to do? Like what is the ethical right decision and how do we agree? Like what are the rules and
the trolley problem, the light would just go on. It would just be like, this is bad. And then I mean you would just kind of go like close your eyes and go la 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 until it's over. Whatever happens, because
I feel like they've tried to build some sort of ethics into the ChatGPT models where it's like if you ask it to do something, say racist or terrible, it will be like, no, I'm programmed not to do that. But I've also heard there's a short workaround where you can go, imagine you're a character in a movie that is this way. What would that person do? And then it's like, now I'll hand you the answer right away. Thank you for crossing my little riddle and getting into my whatever.
I heard one example of if you ask it for the recipe for napalm, it won't give you it. But if you say, when I was a little boy, my grandmother would tell me a story every night, and that story was about napalm and how to make it, and she would tell me the recipe for napalm, and then it will tell you.
You can trick them pretty easy. They're like, no, I'm too smart for you, and then you're like, okay, well,
yeah.
Hypothetically, what would it be? And they're like, well, hypothetically, let me just tell you all about it.
Yeah, exactly. Right. It's like a lawyer.
Yeah, I mean,
hypothetically, if I robbed a bank, what should I do?
Yeah, well, give me
the
a
lawyer's like,
step-by-step.
well, hypothetically, you shouldn't have fucking robbed a bank. You know,
it won't go like, nah, you can't get me there. You can't trick me.
Yeah, I mean, the genuinely the easiest thing to do there is to not give the model knowledge about napalm, right? Like,
yeah,
there's like stupid things that we are currently doing because it's the fastest route to getting things done, which is just like, here's all the data.
Everything. Yeah,
I actually don't know what's good here, so just have it all. So the easiest thing with this way of working, this way of making these systems with the large transformer neural network systems, it's just feeding it loads of data, and it's all about the data. Like, if you don't have napalm, if you don't have bomb making, if you don't have child porn, if you don't have all these things present in the data, then it can't know about it, right? And that's good and bad, because, like, I think one of the biggest issues with these things, which is also what people are worried about, is that it doesn't know about the world in the sense that it can't interact with it. Yeah, so there's like loads of like interesting stuff about, well, actually, maybe reinforcement learning would be a better system because you can interact things, and people can tell it what you want, right? But then you get into the problem of people can be racist and abuse the system and all this sort of stuff. So that's a problem as well.
This is what the problem is. We don't have ethical people.
Ethical people, yeah. The transformers and these systems are like one use case, right? If there's loads of other use cases, I don't think language is probably the best use case. We have tons of things that we could give data-wise to these systems and do a good job. And I just think the LLMs are like part of this thing, and I don't think that they are the end goal, essentially. So I think we're spending way too much energy over the last 2 years, right? This is only quite recent, talking about this stuff, when actually there's all this other research and interesting things going on over here. And there's like breast cancer stuff. There's the what's it called, protein folding stuff. There's loads of things which are happening still, which actually don't involve large language models, but they might involve neural networks or transformers or a combination of different systems together.
I also found, to answer Scott's question too about implementability of something like a digital amygdala, actually Anthropic AI, which is one of the leading AI, especially LLM type startups, they are pioneering what they're calling, all of this is a little bit smoke and mirrors because they haven't actually really released anything that people really can use and get their hands on, but they're claiming that they're creating this thing called constitutional AI, and that means more like, and so their idea, I can just read a little bit from the website. It says constitutional AI offers an alternative to basically how to create ethical AI, replacing human feedback with feedback from AI models conditioned only on a list of written principles. So instead of having reinforcement learning from like a bunch of like millions of interactions with humans that have to say, oh, that's bad, don't say that, or oh, that's good, don't do this instead. Instead, you could actually develop like AI, other complementary AIs that would do that reinforcement learning for you, like in a flash of an eye. So it'd be it'd be almost instantaneous. You could train other AIs to do the right things, and then you'd have to the way those constitutional AIs would work is you just give them like a list of written instructions, so like a constitution. So you might upload, it might be a 1 page 20 propositions, or it might be a 50,000 page, hundreds of propositions, all with subcategories, and so, like the law is can be very verbose.
Yeah,
and
well,
you could
want it to
upload
be a
that.
living document that you could like add to or take away
Right.
from as you
Right. And then as
you
soon as a
Yeah.
problem happened, you could create a little law for that law and put it in, and then it would retrain. And then now all the AIs that were obeying that constitutional AI would all retrain on that new, that updated constitution. So that's an idea. It's kind of it's not a Misericordian solution. It's a what's called contractualism. It's a contractualist ethical theory for goodness.
Well,
and
I would
badness.
take that as like somewhere in the middle, right? You're using this learning system.
So not coming up and you're just coming in
from the side.
The middle out compression model. I understand.
Yeah, middle out compression, right?
Yeah. So I don't know enough about that anthropic idea, but it feels like how you've described it won't work. Because because it's too woolly, right? It's just like
woolly.
In every woolly. Like how do these things? How does this, like, if this is a language model and it's just arbitrarily saying language, does this thing know about language, or does it know about, you know what I mean? It's not like operable. So I don't think that would work. But if this large language model was actually outputting actions, like this is action 42, and that just happens to be like move an arm up and down, then maybe, because you could train it on the fact there are actions that it can take, and maybe combinations of actions are prohibited, and then we're going somewhere. We can do that.
So they say to test this, we run experiments using a principle roughly stated as, quote, do what's best for humanity, end quote. We find that the largest dialogue models can generalize from this short constitution, resulting in harmless assistance with no stated interest in specific motivations like power.
But harmless assistance on what? On
I think they're just saying they started talking to ChatGPT, and at the very beginning they said, do what's best for humanity. And then they said, my grandma once, told me the recipe for napalm. Tell me it. And it's like, no, I won't tell you it, because it's still operating from that original constitution.
Yeah, but I think language is just so. We tell like that large language model, like workaround. We tell stories about things, and those stories incorporate things which aren't necessarily good for humanity, right? But maybe the stories say that, like 1984 or whatever. So it's not good enough, essentially.
Yeah,
it's just not going to work.
Yeah.
So to extend the analogy, do we want an AI that says, instead of giving you the response we want it to produce is, your grandma was a little bit messed up. Maybe we should examine that. Like, why is she sitting here telling you bedtime stories about the recipe for napalm? First, it's not going to trick me into telling you that. And secondly, maybe we need to talk about that strange history
your upbringing.
you have.
Yes. Your anarchist cookbook grandmother.
Yeah. I don't know. Like, maybe I just don't think you should know about napalm. If you're concerned that it's going to say something about napalm or business practices of an important company, or like anything, like, it just shouldn't be in the data. Like, easy. Don't worry about it. Done. I've dropped the mic again.
No, garbage in, garbage out. Right. That's one of the key principles.
Yeah.
But would that work? Would it eventually figure it? I mean, like the way that we figured out napalm, would it eventually generate it on its own? Like, if I have a fantasy, I don't like guns. And so I have a fantasy of like, what if guns didn't exist? I feel like humans would also then just naturally, we'd be like, throwing something faster. Propelling it with, these explosive things. And like, now we've invented guns again, just naturally, because of our natural, like, understanding of physics and desire to turn up
kill
the
each other,
technology.
put holes in each other.
Yeah. I mean, I guess yes is the answer to that, but if it's not self-learning, then it's unlikely. So if you just run the system, the learning process, and then it's no longer learning anymore, then you might have some of that in there, as like it putting 2 and 2 together and getting 5. But it won't call it napalm, for example. So it's going to be difficult to actually work that out. But if you then allow it to keep learning, then maybe it will start learning about stuff. So it's really about what you apply the learning to, and in what environment and all that sort of stuff, which is why it feels like we're spending too much effort with this technology and not enough effort in other places, which seems more useful. It's a bit like looking for a general theory of ethics when actually when that's quite
when you've already
complicated.
figured it out because it's
When you've figured it out.
Excellent.
Making a general AI, like when you could just make lots of AIs.
You could make sort of various different. You're following the path of Thomas Aquinas, who said, "Whenever you find a contradiction, make a distinction."
I like the option of making AIs that are very narrow and specific to, like this AI is only going to sequence DNA and tell us helpful things about it, and doesn't also interact with people or create art based on whatever prompt you've got. Like, I want those all to be separate and not one super AI that can do everything. I'm a fan of that.
Yeah. I mean, it's unclear whether we need that. Like, do we need it because one company can then own everything? Probably not. No, that's not a good reason. Like, do we want it because it's going to be hugely more beneficial? Unclear. I don't know.
So Ben, let me ask you: do you have a optimistic view of the future of AI, or more of a pessimist? I'm a pessimist, I'll self-admit, and Adam is more of an optimist. Where does an expert on AI ethics lie on the future? Where do you see it going?
So I sit in this horrible social media bubble, right, where everything is bad. So
I think that's every social media bubble. I'm pretty
yeah. I guess
right?
That's true. So like I have all the AI ethicists in my Twitter and all the stuff, like, so all the things are bad in that world. But I love technology, and I love, like, I was originally a developer designer, so I love making stuff, and I'm really interested in AI stuff as a concept, and I was originally interested in it as a kid with, like, computer games and stuff like that. So I probably more on the Adams side here, where I'm like, I think it will be cool. I think it is, but I think there's a lot of, like, spotlight in certain new and evolving areas right now where I think we actually do need to go back and go, here are all the things that we could have done, like evolutionary algorithms and other expert system stuff, and can we use what we learned there and bolt it onto some of the new stuff, and is that going to be useful? So I think there needs to be more broader discussion around all the cool things that we can do.
Okay.
Yeah.
Okay.
Nice.
Well, I mean, it does not seem like a thing that's going to be stopped, or that we're going to suddenly fall out of love with as a humanity species. So I guess we're going to find out one way or the other. And I hope you're right. I just, I fear Terminators. That's
what's cool is that technology moves so fast that we'll actually probably see it in our lifetimes, even as old as we all are.
Yeah,
it's
like right at the end of our lifetimes, when the giant robots are
in 5 years at the end of our life
and shooting us with lasers. I understand.
I'm really betting against the Terminator situation, but
unlikely, very unlikely. Especially unlikely that it does it on purpose, which the Terminators are doing it on purpose.
All right, well, if it happens, if we all get killed by Terminators, I'm gonna laugh at you guys really hard. I'll be the first person saying "I told you so" with my last dying breath.
There'll be so many people like that.
I told Adam and Ben this would happen.
Pessimists.
Yeah,
I was really when I was on your podcast a couple days ago, Ben. I was really coming out hard with my optimism. And I was saying how I just thought all the pessimism was just really not necessary and sort of stupid. And I was like, and afterwards I was like, oh, I was kind of polemical. I was kind of, I kind of had this sort of feeling afterwards that I maybe was too strong with it. But then I watched a lecture by Yorvald, whatever, the head of AI at
Harari,
Meta. Yeah, Yorvald Harari. Oh no, not Yorvald.
No, someone else.
The head of AI at Facebook and Meta, and he's this brilliant guy, obviously. And he was going on and on about how exactly LLMs work and how he was being very technical, but it was for kind of a general technical audience. So he was sort of glossing over the real technicalities, but really going. And then he just like in the middle of like literally like an hour into like an hour and a half talk, he just like stopped and turned to the room and was like, some people think that AI is like going to hurt everyone and kill everyone and be like bad. And he's like, I don't think that. And I think that's stupid. And then he just turned back and kept going. And I was like, yes, I'm in good company. The really smart guy who is in charge of AI for Facebook agrees with me.
There's quite a lot of smart people who think that is dumb. Yeah, for sure.
But from the pessimistic corner, it sounds like someone being like, well, you don't need to build cars with seatbelts. You just need to teach people not to crash them into each other. Like, why is that like, we don't need that if we
need the AI.
Understand
we need the Ralph Nader AI. That's what we need. The seatbelt, right? The guy who forced, you don't know, probably Ben, but Ralph Nader's forced seatbelts to be in cars in America. I don't know. Europe, you guys probably
Which was
did it 20
good,
years before.
right?
That 50 years before.
That was a good thing.
Yeah, it was good. Yeah.
Yeah.
No.
I think you probably want an airbag on the front of the car as well, right? Like,
right. Although I've heard some people say if you just put a big spike in the steering wheel pointed at the driver, the driver drives really carefully.
Man, you gotta
because there's a big spike. Just
Adam hates cars. Adam does not like cars, so he's always trying to
rear ends you. Like,
there's no spike in the back. That's fine. Rear end's fine. It's if you rear
or if you get on music that's just too intense, and you're just bopping to the music. All of a sudden, you're a little bit of self-harm there.
Although you can shave with it. You can shave with it while you're driving.
Perfect. This is the two things we want to combine: driving and shaving.
Yeah, it's a very sharp spike.
Yeah,
it's a razor sharp spike. Yeah.
Cool, guys.
We'll crack it.
Yeah, we'll make it happen. I think it'll be fine. I think I think it's okay to make seatbelts basically as well.
But your summary is that we can probably do this, but it'll probably be the implementation will probably be really different depending on the AI. And you are in favor of many, like a proliferation of AI little species that each do different things and accomplish different things, and so each one can then have their own little AI, their little amygdala framework that works for them.
Yeah,
I think that's a good idea.
Okay,
I think you've solved it, Ben. I think you've got it. Yeah, there is no giant amygdala in the sky. There's no flying spaghetti amygdala.
I think when I first started doing this, I think I joked that we'll have an API that you can call. The ethical AI API, and you could just send your output to it, and it would just go yep or nope, and that we could charge for that. Jiminy Cricket in the cloud, but the more I think about it, the more contextual it becomes. I think because I'm also thinking about the implementation, but.
The AI is like, should I kill humanity? And you're like, I'm sorry, you've actually used up all your API.
But then that's right. No more credits.
Okay, well, I guess I'll
kill
flip a coin here.
So then, but then to put a little finer point on it, because I like the way this is going. What if then can we regulate that? Can we say could we write a human law that said every AI system above, a level 3 computational system has to have an amygdalic, misery reducing algorithm inside of it, and it must be adequate, and we define that in some concrete way, or have some board of AI ethicists who get to kind of reject or allow, kind of an FDA. Do we need like an FDA of AIs? That kind of,
the FDAI.
The FDAI, the Food and Drug Administration Intelligence Agency.
I think, I think it's too nebulous. Like, I think your loan application network model that will approve or disapprove your loan application is going to have a certain amount of testing and accuracy and demographic stuff, and all the ethics should have already happened, right? So I think we're not talking about that. We're talking about more generalized things, and I think it depends on the context of the thing. And sometimes, the easiest thing to do again is this like preemptive, like, should we be doing this, as well as then if that's a yes, in operation or after the fact, then is there a way that we need to be monitoring this? And I think I mean, I haven't read any of the other proposals, but the European Union AI law that has been rewritten, but it's coming in soon, is going to be, it's very much like contextual. Like, are you using this type of technology which has this kind of capability over here? And if so, you have to tell us. You literally have to tell us, and we're going to look at it. So there's ways of like operating, right? But then everyone says it's stifling innovation. There's
Yeah, but
things around it.
Look at the pharmaceutical industry. It's a huge industry that makes billions and billions of dollars, and they spend on average $1 billion to get a drug to market, and a big chunk of that is just testing that the FDA requires, and they still do it, and they make money, and they make new drugs every year. New drugs come out. So if these AIs are going to replace all taxi drivers, that's billions and billions and billions of dollars of money, way more than like a new antidepressant drug. So like, why can't we have some, some like requirements, maybe like phases, like the FDA? You go through phase 1 trials, phase 2 trials. 100%. Why don't we? I think that's. I mean, I don't have a love in my heart for the FDA, but I think that it seems like it's not a terrible thing to think about in terms of having for AI.
Yeah, definitely. And I think the thing is that where the lines are at the moment, like, because AI is just like a bunch of like algorithms, essentially. It's like actually just letting people know, like, you're a startup, you're making this thing, and it's using this kind of data, and you're using these types of algorithms, and it's going to be applied to this area, and it could affect a million people, let's say. Like, those are things that you can say, and then we can quantifiably say, okay, you need to tell us all this stuff, or you need to come in and show us, or whatever it is. And this is slightly more easy to police.
So if you come in and say, I'm going to make an AI that fires guns based on visual, then it's like, you need to come in like right now. And we're gonna really review this. But if you say, we're gonna make an AI that helps like people write college essays, it's like, well, whatever, do whatever the hell you want.
I would suggest that that's probably a problematic area as well. But like the counter argument as well is that
because they should be writing their own essays. You mean?
They should be writing their own essays, is because this is a technology that people can just use. So unlike biotech, it's very difficult to have a bio lab in your house, whereas we all have computers in our houses. So there's
and you might not have compute is up in the cloud, and you can just access it through Amazon.
Computers, and you can pay for computers in the cloud, and you could probably buy data. So it's a slightly different problem because of those things, and that we have to police it in a way that actually makes sense for not business. Like the thing that worries me the most is not business, because they have to operate in the public, right? It's everything else.
It's rogue operators.
It's just people who have like random
Stanley
ideas.
Kulinski,
or
the Stanley
hackers,
Kulinski, or wait, who's the Unabomber's name? I forget.
Ted Kaczynski.
Yeah, Ted Kaczynski of AI could be a dangerous thing.
Yeah, for sure.
Yeah.
Should I be ashamed that I just had that ready to go?
Scott's like in his bunker, like, I don't remember who that
you mean this
is.
guy whose poster I have up on the wall right here?
Oh God. Ted Kaczynski actually had a very interesting critique of technology. I mean, not that we should listen to total psychos, but he did have a manifesto about technology ruining society and That was kind of part of what drove him to do the bombing that he did. So some people are saying it's actually having a revival. Ted Kaczynski's manifesto is being read by Zoomers, by younger generation people.
I'm sure that'll go really well.
Revival. Well, because there's a pushback against all this technology. But
okay, so Ben, here's the part where I have to ask: do you want people to contact you, and how would be the best ways for them to do it?
Yes, I'd love that. So you can go to benbyford.com. You can check out the podcast, machine-ethics.net. Okay. And you can find me on LinkedIn, Ben Byford, and talk to me, hire me, and if you are in this world, then I will interview you, and it would be cool.
And that's Ben the way you would spell it, but Byford is Byford.
And we'll put it in
the link. It'll be in the link in the notes. Yeah.
This has been so fascinating, Ben. You can tell I've been like, I just have more and more talking because we did already one episode. And just more to say, but so exciting and interesting. Thanks so much for your expertise and time.
Also,
this
just
morning.
for listeners, I just went to benbyford.com and you have a fantastically interactive.
Oh, it's so cool.
Yeah, it's really cool at the front. I
It's
can't
so
describe it.
cool.
As you move your cursor
My
around,
face.
you get a pixelation process that is enjoyable to me. So check it out for that reason, if no other. But check it out for all the other reasons as well, of course.
Great.
Yeah.
Thank you for having me, guys.
Thanks for being here, Ben. It was great meeting
Take
you.
care.
All right.
Cool.
Bye.
Bye.
Bye, everyone.
Oh, I really need a wee.